Hi, and welcome to the third part of the series in which we are learning Arduino programming. In this part, we will be showing you how to introduce the analog data into an Arduino and using it for our interfacing with the external world. For this example, this is the diagram that we have connected. We have connected a 0 to 5 volt completely variable voltage supply to pin number A0 as it is shown on the Arduino Uno board analog in, and there are 1, 0, 1, 2, 3, 4, 5. There are 6 ADCs, 10-bit ADCs inside this 80 mega IC, which are visible on this board. So we will be showing you by programming only the first A0. Likewise you can use A0, A1, A2, A3, A4, A5 for your program. Now I'll give you a brief intro about the program that we'll be using. We are going to vary the voltage 0 to 5 volt, and this 0 to 5 volt we are going to sense in the program using a variable, and this variable will output the corresponding digital values onto the serial port. Now let me take you to the program step by step. Now that you have understood the connection diagram that we'll be using in this program, let me take you to the technicals. In the last 20 years, before the last 2 decades, all the microcontrollers, whether 8-bit, 16-bit, did not had their A to D and DAC on board. But with the advent of the latest technologies, they have implemented ADCs on their board itself. One of the prime example is an Arduino board. Now let us understand why do we need in this ADC at all, when all the things that we use in daily lives are digital in nature. This is a very big misconception in our understanding. Analog data is the most common form of data that is used in instrumentation, measurement, or any control appliances. So it has to be converted to digital data to be understood by the microcontroller or any other measuring device. So there we need an ADC. Now Arduino has a 10-bit ADC, which means that the output there is a 2 to the power 10 values that can accuracy that you can get in an ADC. So that now that you have understood the theoretical concept of why do we need an ADC in a microcontroller, let us take you to the program. First of all, we have to understand there is no need to initialize an analog pin to an ADC. So straight away we go to the loop. In this loop we have defined a variable sensor value that reads the value of analog signal A0. As I have already shown you in the program, let me again show you in the program, in the diagram, that A0 has been connected with an analog voltage 0 to 5 volt, and this value has been put in the value sensor value. This command serial.println sensor value will display the value read on the analog input in the form of 120 1023 on the value sensor value, and it will be printed on the serial port. Now how do we connect? How have we initialized the serial port, and how have we be able to print out the output on the serial port? So by using this simple command serial.begin, and this is the baud rate, serial begin. Here we mention the baud rate at which it sends out the data. Now this is an example of asynchronous transmission of data. What does asynchronous transmission of data means? That means that there is only one-way communication between the sender and the receiver. There is no feedback. To display the same value on 8 LEDs, you have to display the same value on 8 LEDs. You have to simply divide the value on by 8 and output the result on a LED. So you will see your output in a percentage of 8. For example, if all the 8 LEDs are glowing, that means you have reached the full values. 8 LEDs glowing, then 100% analog voltage, IP 5 volts. Similarly, if 4 LEDs glowing, then 50% voltage is 2.5 volt. If 2 LEDs are glowing, then the output is 25%. I hope you have understood the basic formula that I am trying to explain you here using percentage mathematics. I hope you have liked this video. I tried to contain all the relevant information required to run an ADC, to run the internal ADC with Arduino, and I hope you like it. If you like it, please suggest me in the comment section, and do not forget to subscribe and like. Bye bye.